Okay? And what has happened in the past is that I've given this quiz twice. Because what has happened in the past, not saying this happens with you, but what's happened in the past is about half the kids do great and get like perfect or close to perfect, and the other half do terrible. And we can't go forward if you don't have this memorized. So I give you a couple more days and we take the quiz again. But here's the rule. If you're happy with your first score, like let's say you get a 16 out of 16, and you don't have to take it the second time, you just get another 16 automatically. If you got a 14 out of 16 and you're happy with that, then you can just not take the second one and get another 14 out of 16. Okay? The idea is you have this stuff memorized. So what I did was I put together just a little practice quiz, just so you would kind of know what the questions are going to look like. And I thought we would go through this together. Okay? Probably, I don't remember. And it counts. The second one counts. Are you okay?
Bro, watch out, man. You just touched me.
Actually, you touched him. His hand was already there.
No, okay, his hand was close to my face.
Well, you initiated
Shut
contact.
up.
Just 8 little
I
questions
didn't
here.
initiate nothing.
And these are not the same questions as are on the quiz. But they're the same kinds of questions that are on the quiz. Okay? So number 1. Sine equals what? What do you think? There are actually 2 options. Curving.
No, we didn't get in.
Oh, I don't know how that happened. Sorry about that, guys. Sine equals what? What does sine equal? You have 2 options. Opposite over hypotenuse. And if you're having a hard time remember that, remember SOHCAHTOA. Maybe at the top of your page you want to write SOHCAHTOA. Now, if you don't spell it right, you're in trouble. So make sure if you're going to write it up there, you spell it correctly. But sine is opposite over hypotenuse. Anybody know what else sine is? Somebody said it. Y over R. That's exactly right. Good job, Liam. Y over R. It is Y over R. Okay? Number 2. What's X? That's one of your special triangles. What is X? If the 60 is here, what number goes across from the X? Root 3. The square root of 3. In a 30, 60, 90 triangle, you have 1 across from the 30. 2 is on the hypotenuse, and root 3 is down here across from the 60. Okay? Sine over cosine. I might have gotten carried away. Did I have that on your sheet? No, I don't. So instead of sine over cosine, let's erase that and make it opposite over adjacent. What is opposite over adjacent? That's tangent. So that answer would be tangent. Tangent is sine over cosine, and you can abbreviate and just write tan. Tangent is sine over cosine, but you don't need to know that yet. That's actually the first part of chapter 5. I don't know what I was thinking.
Do you care if we abbreviate it?
No, you can. Abbreviation's fine. What's the abbreviation for cosine? COS. COS. No hoods, Chris. What is the reciprocal of the cosecant? The sine. Remember, no cos go together. So cosine goes with secant, and sine goes with cosecant. The reciprocal of the cosecant is the sine. Very, very good. How about number 6? If this is 1, this is 1, this is root 2, and that's 90, this would be a 45-degree angle. Yep, that's exactly right. That's a little 45, 45, 90 triangle. Number 7. Theta is right here, and that's important. You have to pay attention to where that angle is, because where the angle is going to tell you what is opposite and adjacent, right? This is the hypotenuse always. That'll never change. But which one's opposite, the 5 or the 12? The 5 is opposite. And the 12 is adjacent, if we're talking about that angle, which we are. So what's the tangent? 5/12. Opposite over adjacent, 5/12. Tangent, toe off, opposite over adjacent. SEC is the abbreviation for, not cosine, it's the abbreviation for secant. It's the reciprocal of the cosine, but it's the abbreviation for secant. So on your quiz tomorrow, you're going to have to know the abbreviations, right? The reciprocals, the triangles, and the definitions. Okay? I am not putting on the quiz any of the X, Y, and R, any what we call the circular definitions. If you put them on there, you'll get full credit. I mean, it's correct, but I'm not going to ask you what's X over R. I'm not going to ask that question. Okay? Anybody have a question about that? Let's get through a few things, and then if we have time, I'll throw some more review at you, and you can practice a little bit. We'll see how good you are. All right, but let's get through a little bit first. So back to our notes. We're on page 32 now. You know, if you take another class, you're going to have more homework.
We don't.
There's no homework in that class?
We don't really take tests in that class. So.
What class?
Sports.
Oh, yeah, that's the easiest class ever.
Even this one?
It's mostly like just like discussion topics.
You just watch 30 for 30s pretty much.
I didn't know what that is, but okay.
Oh.
All right, here we go. Problem A. We are going to find everything. So this will be good practice for your definitions. We are going to find the sine, the cosine, and the tangent, and the cosecant, and the secant, and the cotangent. And our picture is 2, 3, root 13, and theta. There it is.
Theta.
And I'm going to have to move these over a little bit. Need a little more room. Now, this is actually a really easy problem if you know your definitions. That's the key. Okay? So here we are. Here's theta. Which side is this? Opposite. And this one is adjacent. And this one is hypotenuse. What's sine? I erased SOHCAHTOA. I should have left it up there.
Did you go on the call button?
I didn't.
Okay, thanks.
Sorry. I mean, I don't know. Did any of you bump into it or something?
Where's it at?
Where's it at?
It's over there somewhere. It might be behind the cosine. Actually, I should know that because I did actually press it once. And
Remember,
Michelle went first.
oh, here it is, right here. Okay. All right, so find the sine. All right, sine is opposite over hypotenuse. So did you get 2 over root 13? But we're going to do our basic arithmetic, and we're going to multiply top and bottom by root 13. So we have 2 root 13 over 13. That will be our final answer. Now, when I move over here to do the cosecant, which is the reciprocal of the sine, I'm going to flip the original. Because if I flip the original, I'll have root 13 over 2. What happens if I flip the actual final answer? What will be in the denominator? Another radical, and I don't want radicals down there. So instead of flipping the final answer, I'm going to flip my original. Alright, what's the cosine? For this triangle right here, the cosine. 3 over root 13, which I'll do the same thing I did here, so I get 3 root 13 over 13. Is that right? Now, when I flip it, I'm going to flip this one, so the secant will be root 13 over 3. What about tangent? 2 over 3. Tangent is opposite over adjacent. So if you have them labeled, you know it's going to be 2 over 3, which means the cotangent then is 3 over 2. Everybody okay with that? Now, the next one is exactly the same thing, only it doesn't even have any radicals in it. What I need you to pay attention to on this next one is, look where theta is. So when we're talking about adjacent and all that stuff, you've got to pay attention to theta. Okay? So there it is, up there at the top. Which side is opposite? The 5 is the opposite side this time. This is, of course, the hypotenuse, and this is the adjacent. Does that make sense to everybody? You've got to be able to know which one's adjacent and opposite, or you're going to be in trouble here. Asia, you good with that? All right, so now we're ready to go. Here's SOHCAHTOA. What's the sign? Using this opposite adjacent hypotenuse, what's the sign? 5/13, which means the cosecant is 13/5. Remember, these guys are reciprocals of each other. What's the cosine? 12 over 13, which means the secant is 13 over 12. What's the tangent? 5 over 12, which means your cotangent then is 12 over 5. Okay, you all right with that? That's an easy way to get a bunch of points, but if I'm not here talking to you, you got to remember what these things are, okay? Now, what's different about problem C? There's a side missing in the triangle, isn't there? How are we going to figure out what that missing side is? What? What do we call that? You're right, Joseph James.
Some theorem.
Some theorem. Starts with a P.
Or Pythagorean
The
theorem.
Pythagorean theorem. We're going to do the Pythagorean theorem. In order to do question C, you have to have all 3 sides of the triangle. We do not. We have a 1 and a 3. We are missing this side. We have our adjacent and we have our opposite, but we are missing our hypotenuse. We can't answer all these questions till we find it. So, what does the Pythagorean theorem say? A squared plus b squared equals c squared. So 1 plus 9 equals c squared. So what does c equal? The square root of 10. We're square rooting both sides. So it equals the square root of 10.
How do you know what's A and what's B?
It does not matter what's A and what's B. C is always the hypotenuse. But what you put in for A and B doesn't matter because you're adding them and you can do it in either order. But C must be the hypotenuse. C must be the hypotenuse. Now I also, on these sheets here, I did not write down all the functions. I got tired of writing them all down. So now you got to write them all down. And part of the reason I want you to write them down is I want you to get used to matching up sine with cosecant, cosine with secant, and tan with cotan. So do it in that order, just like I did, so you get in the habit of matching them up, lining them up. Okay? And to make a theta, I always just draw a circle and put a loop, but some people draw a circle and put a line through it. Mr. Knoll does it that way. Doesn't matter, either one's fine. And honestly, if you don't like the thetas, change them to something else. You can make them x's if they make you uncomfortable. All right, so here we go. What's our sine? Okay, good. You even rationalize. It's technically, step 1, 3 over root 10, but that's going to become 3 root 10 over 10. Very, very good.
Why do we do that?
Because a number with a radical is an irrational number, okay? And an irrational number is a number that never terminates and never repeats. So in a division problem, this would be 3 divided by root 10, right? But root 10 is this decimal that goes on forever and ever and ever and never repeats and never terminates. So it wouldn't be possible to do this division. You see what I'm saying? So since we can't divide by it, we get it out of there and put it into the numerator. Now, if it's in the numerator, it's here. And is it okay to have a whole bunch of numbers there? Yeah, you can still do the division. It goes on forever and ever, but you can do it. Now, if the sine was 3 over root 10, then your cosecant is going to be root 10 over 3. Get in the habit of flipping step 1 if there's a radical involved. What's the cosine? 1 over root 10, which is root 10 over 10, and if you put a 1 here, that's fine, but you don't need it. I'll just put root 10 over 10. That means my secant, what's my secant?
Root 10.
Root 10 over 1, which is just root 10, very, very good. And what's my tangent?
3 over 1.
3 over 1, you can write 3 over 1, or you can just write 3. If you write 3 over 1, that helps you, remind you that the cotangent is going to be 1 over 3. Are we starting to feel pretty good about that? All right, then would you do D by yourself? Now, my caution is, again, you got a side missing, right? You have to find that side. So you're going to do your Pythagorean Theorem, which is a squared plus b squared equals c squared. That's your Pythagorean Theorem. Be careful on this one. I'm looking at problem D. What's missing? What do you not have? Either A or B, right? I don't care which one you call it. But C is 5. So you're going to put 5 squared here. And then one of these is going to be your variable. So go ahead, give it a shot. I got root 21 for my third side. Does anybody have a question about that? I got root 21. Everybody's getting it?
No.
You have a question about it?
Yeah.
No? You do?
Yeah.
2 squared is 4. So when I subtract 4, I get 21. And then I need to take the square root of that. So is everybody okay with the 21? Now, what is that root 21? Is that opposite, adjacent, or hypotenuse? That's opposite. For this problem, it's opposite, because it's across from the theta. Pay attention to where the theta is. So what's our sign?
Root 21 over 5.
Root 21 over 5. Now, we do not have to worry about that. That is fine. We only get, have to do stuff if the radical is in the bottom. This is fine. But when I flip it, I'm going to get 5 over root 21, right? That is not fine. So that will be 5 root 21 over 21. What's my cosine? 2/5, which means my secant is 5/2. And my tangent? No, tangent's not 5 over 2. Secant's 5 over 2. What's my tangent? Root 21 over 2? Which means my cotangent is 2 over root 21, which is 2 root 21 over 21 as my final answer. What do you think? You all right with that? You could probably have a quiz over that, couldn't you? Maybe?
Yeah.
Good. All right, let's look at number 2, because actually part 2 is exactly the same thing. It looks different. You look at it and say, wait, that doesn't look the same, but it actually is. Here's what's going on. I'm going to erase SOHCAHTOA and see if we can remember it now. Here's what's going on. I drew a triangle for you, so I'd like you to take that triangle. And I've said sine theta is 2/3. I gave you that value. Now, even without doing anything else, can you fill in the cosecant? Can you fill that one in? Yep, you don't need to do a darn thing. You know that's going to be 3/2. So already you get partial credit, haven't you done any work. Now, I'm going to put theta right here. You can put it up here if you want, but in the future we'll be using it right here at the origin, so I'm just going to kind of get in the habit of putting it at the origin. And the sine is 2/3. Now, I'm going to put that 2 and that 3 into my picture. Where am I going to do that? Trey?
Except for where?
Yeah, I'm going to, somewhere here, 3 sides, somewhere, somebody's going to be 2 and somebody's going to be 3. I want the sine to be 2 over 3. So where do you think the 2 might go? The 2's going to be the opposite side, and the opposite side would be here. Opposite.
Would be right there, right?
And 3 would be right here because it's the hypotenuse. So now we have the same situation we had a minute ago. I have to fill in the rest of this, but I'm missing something in my picture. So I'll have to do the Pythagorean Theorem.
Which ones are A, B, and C again?
Okay, C is the hypotenuse. A and B don't matter. Doesn't matter. It doesn't matter which one is A and B, but this has got to be C. So I might say A squared plus 4 equals 9. Because A squared plus 2 squared equals 3 squared. Does that make sense to you? So what does A squared equal? A squared equals 5. So A is going to be the square root of 5. Now, we can fill in everything else. Once we get our triangle drawn, we can fill everything in. So what's the cosine going to be? Root 5 over 3. Nothing wrong with that. But when you flip it, you get 3 over root 5. with 3 root 5 over 5. Yep. Somebody got a question? What's the tangent?
2 times square root of 5 over 5.
2 over root 5 is step 1, opposite over adjacent. But that'll be 2 root 5 over 5. But when I flip it, oh, that's not tangent, that's cotangent. When I flip it,
Root of 5 over 2.
I'm going to flip step 1, so I have root 5 over 2. Is that right? Is this the lunch period?
Yeah.
Well, I need to pay attention to that then, don't I? Let's do the next one. Is there another one like that? All right, I'm gonna do one more of these with you, and then you're gonna do the other 2 and go to lunch, okay? So here we go. Let's do one more together.
Probably this one.
So notice I drew that same picture again. I did not draw it for C and D, so you're gonna have to draw your own in C and D. You'll do it just like I did. You'll draw a little triangle just sitting here just like this, and you'll call this theta. We're on B now. We're on problem B on the back of page 32. Now, this time, I gave you the cotangent. So I said the cotangent is 1/4. Which means what automatically? The tangent is 4 over 1. So then I can look up at my picture, and I can do some labeling now. Soka Toa. Tangent is opposite over adjacent, right? So the opposite side is 4, and the adjacent side is 1. Then I do a squared, that's right, Trey. A squared plus b squared equals c squared. So here's my A and my B. Emily?
Why couldn't, where the 4 is, why couldn't that be 8 and then where the 1 is be 2?
It could. It absolutely
Would you still
could.
get the same answer?
You're going to get exactly the same answer, because what's going to happen if you do that, Emily? When you start building your fractions, things are going to cancel out. So if we use the smallest possible numbers, 4 and 1, then we're not going to have canceling to do.
Okay.
If you used 8 and 2, eventually you're going to get the same answer, but you're going to have to do some canceling, because you would never leave it 8 over 2. You'd cancel that out. Very good question. All right, have you figured out what this third side is now? That's the hypotenuse. So I hope you said root 17. Why is it root 17? A squared is 1, B squared is 16. Add them together to get C, right? So what's my sign? Sounds like a date pickup line, doesn't it? Opposite over hypotenuse. So 4 root 17 over 17. What's my cosecant?
17 over 4.
Root 17 over 4. Perfect. Beautiful. We flip this step right here. What's my cosine?
1 over root 17.
1 over root 17.
Which is 1 root 17 over 17.
Yep, that's right, exactly. But I'm going to flip this one. So my secant is root 17 over 1, or just plain root 17. here's what I want you to do. There's two more. Now, for C and D, you're gonna have to draw your own triangle. I didn't even draw the triangle, but go ahead and draw this triangle for C and D. And let's go ahead and label those two, so we're using the right numbers. Make sure everybody's got that. So, and then you're gonna fill in all the blanks, and then you can go to lunch, okay? So first thing we're gonna do is problem C. Draw your little triangle over here for problem C. And then they tell us that the cosine is √5/3. Now you gotta put that in the picture. Alright, so where are you gonna put the √5 and where are you gonna put the 3? John?
So the root 5 is going to be on the bottom.
√5 is gonna be the adjacent side, it's gonna be on the bottom, you are right. And where's the 3 gonna be? On the hypotenuse, perfect. So before you can fill in the rest of the blanks, you're gonna have to find that third side. So it's gonna be √5 squared plus b squared equals 3 squared, and Robbie, you're right. √5 squared is just 5. These cancel. So it's gonna be 5 plus b squared equals 9. B squared equals 4, which means b equals 2. So there's your picture for number C. So you can fill in all the things. Now let's do the picture for D. This one, they tell me that the cosecant is √17 over.
Miss Ford.
It's the same as this question, isn't it? The cosecant is √17 over 4.
Yeah.
All right, so just cross that one off. Work on to finish up C. Everybody bring me your notes with C done. If you want to fill in D, go ahead, but D is exactly like me. You cannot beat me, okay? I have got to get this done before you come up here, okay? I mean, you can stay up here, but I need a minute to get caught up, all right? You beat me. Yep. D is going to match B exactly, so if you want to go ahead and fill that in, you can. D and D are the same problem. D and D are exactly the same problem. Oh, what's the square root of 4? Yeah, we should always. Yeah, but we should have that on all. All right. How's our you know, that girl was not like that. Okay. Looks like we're doing okay. How would you feel about a little quiz when we come back? Yeah, maybe practice one first and then. I think you're ready. You're an amazing human being. You're doing
Yeah.
I did.
But you were
Any day I get to sit on the side of your guys, it's a good day. Right?
Not a good day.
How do you feel? That's same way.
Just do a good day.
What's the
Oh,
Be careful of that, okay? You might want to write at the top of your page. So, just to remind you. Okay. You.
Hey, thanks.
Scott, how are you doing? Do you care? I mean, is that a big deal?
Yeah, they beat you 1-0, number one.
You don't wanna get money.
Buzzer.
Oh, it is. Problem is, isn't Villanova at Catholic school?
No.
Well, yeah.
But it's not one of those.
It's a win-win.
Who sent you up here? Who? Where's Trey? Trey? Why is she bringing your paper up here? He gets to wait in his own line, yes. Screwball. Perfect. Doing great.
Oh.
You're on the right page. All right, see you guys.
Skip rotation.
Raven, will you smile? Just smile. Make my day. Smile. Okay, now did you do some corrections? Did you figure this out, or somebody help you, or what? I see you process this. Okay. Just so you know what you're doing, so if I give a quiz, you're ready. Now. Okay, now here's the deal. See that right there? You can't read that, radical at the bottom. Right, and this is gonna be the same thing. Okay? Don't forget to do that, because that'll be like a half a point off. All right, what are you doing?
I got one too. I just thermal.
Okay, now tangent and sine can't do the same thing.
You do that to tell me, blue. It's like blue.
Okay, so that's right, okay. As long as you can find your tangent, okay, never toe off. How are you, Austin? I'm hunky-dory. Yeah, something's not right. Okay, remember, sine and cosecant are reciprocals. So this, if that's 2/3, which I was correct, this should be 3/2.
Yeah.
All right, so you need to fix those. You got a couple of them mixed up, it looks like.
I don't know why.
Okay. You forgot to rationalize, so forget. Get that out of the
I wrote my I made some of my cosecant.
Yeah, but you were the first one to turn your paper up, and now did I check it already? Okay, so this is good, John, except remember we have to rationalize that. So do you know how to do that? If you have 2/5, do you know how to do this part? Multiply top and bottom on root 5. Whatever that is, multiply top and bottom by that, and then that will cancel to be just a plain 5. And on the top you have 2/5.
What time we're supposed to be back?
Did it with that one. Oh, I didn't tell you, did I? Well, it should be 12:20. So hopefully they'll be back.
I don't know why.
You understand it though?
Yeah.
Are yours correct? Do you think, or do I need to check it for you? I've got, yeah, they're right. to be doing that, do we?